up is the D latch, which is a very minor variation of the SR latch. So you look at the SR latch with enable input, this is the setup, and now you look at the D latch. If you compare both the circuit diagrams, you will notice that there is only one difference. In the SR latch, you had a separate input called R coming in here, whereas in this latch, the second input is merely the complement of the first. So how does this help? Again, when your enable input is equal to 0, irrespective of what your D and D complement are, both the inputs are going to be 1, 1. So it will act like your retain mode in your NAND implementation. So when both the inputs are 1 in a NAND version of an SR, it just retains its previous state, right? So that is what will happen when enable is 0. When enable is 1, you can approximate D equals S and D bar equals R. So you will notice that the only input combinations possible, provided enable is a 1, are S0 R1 or S1 R0, where S and R are nothing but your D and D bar respectively. So you cannot have 0 0 or 1 1. So what happens here is when D is 0, D bar is 1, it is equal to the S0 R1 state of your NOR implementation. So it becomes Q0 Q bar 1, and when D1 D bar 0, it becomes vice versa. So that is the transparent flip-flop. So what is the big deal about this? So your choice of flip-flop for building a sequential circuit depends upon what application you are going to deploy it in, right? So what is the kind of what is the end goal of the device you are trying to build? So if you were trying to build a device where you either want to set or reset, you don't need to retain the previous state, or if that application is not necessary, and if you most certainly do not want it to fall into the forbidden or invalid state. See, if you want to retain, you can just set enable to 0, so that function is available, and both set and reset functions are also available. So effectively what this is doing is making sure your system can never fall into the forbidden state. So if falling into the forbidden state is a very costly error which your device cannot afford to make for some reason, then it would be a better idea to use a D latch instead of an SR1. So that's it about D latch.